Hello students, today we are going to learn a new chapter that you can see on screen is known as address calculation. Now address calculation means we have to find out the address of a particular cell of a 1D array or of the 2D array which is being saved in our main memory, that is in our RAM. We all know whenever we are going to run a Java program, the Java program runs on our random access memory, that is on our RAM. That is why whatever variables or whatever values we used to save in our variables is not permanent. They are all volatile, as because RAM itself is a volatile memory. That means if we are going to run a Java program, at the beginning I had given int a equals to 10. At the end of the program I got int a, I had updated the value with plus or something like that. I had got some value. Next time whenever I am going to run the program, I may get a different value, because at the beginning I had given the value 10. I had entered a value 10 in the variable array. Now I want to enter 7 in that variable. So each time the value is depend on the users, and these values is being saved in a variable. That means now what do you mean by a variable? A variable is a named memory location. That means again, see, the memory locations used to come. Whenever a memory location will come, that means an address should come over there. Each memory locations in a RAM has got an address through which the compiler or the operating system is to find out which value is or what value should be saved in a particular memory location. That means name is assigned to a memory location. So we have to know how does this happens in our RAM. Let's move to the next screen. Address calculation for 1D array. Now see, you can see on the screen is that the memory addresses, the values and the index numbers has been given in the 3 rows. The first row contains the memory addresses, the second row contains the values, and the third row contains the index numbers. I am starting from the index number. If suppose this is a 1D array of name suppose A, then of size 10. If I say this array has got a size 10, so the index numbers should start from 0 till 9, isn't it? So these index numbers is being written over here on this screen is with red ink. Now each and every index numbers represents a cell. Each cell has got a values. That's why we can say A of 1, A of 0, A of 3, A of 4. Now if I say A of 0 contains 2, now see the black ink, the numbers has been written using black ink, where A of 0 contains 2, A of 1 contains 55, A of 2 contains 9, A of 3 contains 6, and so on. So these red ink, the numbers written with red ink are the index numbers, and the numbers written with black ink is of values of the particular array. Now this array is being saved in the memory, that is in the RAM, isn't it? Now I just now at the just few seconds before I had told you that the RAM has got, or each and every variables in the RAM has got a memory address. Now this memory address is basically of hex code, or you may say binary numbers. If I say hex code or anything like that, so the blue pen written with blue pen is a hex code. If I say, or over here I have written this memory addresses as not hex code, as a simple decimal number to make you guys understand. Now see, the first memory address is 101. This memory address is being called as base address. That means the memory address of the first cell of an array is always known as a base address, because by which we can always understand where to go or how to move to the next cell. Now see, if suppose if I consider that this array is of integer type in Java, so in Java, integer type variable contains 4 bytes. Now, see, the first or the base address of a of 0 is 101. So the address of a of 1 will be 105 because it contains 4 bytes. So 101 plus 4 is 105. Similarly, the address of a of 2 will be 109 and so on. See, each and every address is increased by 4 bytes. If suppose this array is of character type, then it is going to increase by 2, or if it is of double type, then it is going to increase by 8. It's as simple as that. It's very easy. So this is how we used to save or compilers used to save the values in the memory. Now see, just below that, it's being given over here, address of an element of an array, say a of I. That means the array name is a and I is the index. If I say I is 6, that means the address of a of 6 is equals to 125. We need to find out this address. That means a formula should be there. If I need to discuss you the formula, before discussing the formula, I want to solve this sum. So I told you a of 6. That means a is the array name and 6 is the index. Now see how many cells are there just before the 6th cell or the 6th index. See, there are 6 cells are there before the 6th index, that is from 0 to 5. 6 cells are there. So if I multiply 6 with the total number of bytes for each cells, that is 4. So 6 into 4 is 24 plus the base address of the first cell is 101. So see, 101 plus 24 is going to come as 125, which is the address of the 6th index position of the given array. This is how we are going to calculate the address of a given cell number or index position in a 1D array, where C is written over here, address of a of I is equal to b plus w into I minus lb, where b is the base address, w is the storage size of one element stored in the array in byte. That means the data type or the size of each data type which is being used in the array. I is the index position of in the given array whose address we need to find, and LB is the lower bound of the array, where in which for this LB you need to say if the array is simple, an array has been given to you, that means the lower bound will always be 0. But if the lower bound and the upper bound is being given, so make sure, suppose if the lower bound is being told minus 10 till minus plus 20, that means the lower bound will be minus 10. You're going to come with all these type of sums in the next few slides, or I'm going to show you why these are different, or how is going to be a different thing. The next slide, you can see a simple calculations has been given. The first example has been given the base address of an array b of 10 as 500. That means the base address of this array b of 10 is 500. That means this array starts from the 0th location, because it's a simple array given. No initial index as well as the last index is not being given over here. So 10 is the number of elements present in this given array, where b of 0, which is the first cell of this B array, is saved in the memory location 500, and each cells over here takes 2 bytes of memory. So the question asks us to find out the address of B of 5. So see, the base address is equal to 500, lower bound is equal to 0, width equals to 2, and I equals to 5. We simply is going to plot all the values in the given formula in the last. The given formula is being given in the last slide. We are going to use that formula. Address of a of I is equal to b plus w into I minus lb. So 500 plus 2 into 5 minus 0 is going to come as 500 plus 10, that is equal to 510. It's very simple. So the next one, the second example, where the base address of an array be 1300 till 1900 as 1020. Now see, the base address of the array B is 1020, that means which is the first cell number, which is the first index number of the given array. It's 1300. That means the lower bound of this array is 1300 and the upper bound of this array is 1900. It's again being told the width of each cell is 2 bytes and we need to calculate the address for B of 1700. So the base address is equals to 1020, lower bound is 1300, width equals to 2 and I equals to 1700. We need to plot all these values into the formula again and we are going to get the answer as 1820. This is as simple as that. Now we are going to move on to the next slide, which is going to where we are going to find out the address calculation or address of a 2D array. Now see, over here the 2D array is given where the row index and the column index has been mentioned over here, which starts from 0 and the columns ends over here as 3 and the row starts from 0 till 2 and the values has been given. This 2D array, the calculation or the in memory, many compilers, it depends on the compilers actually, in memory many compilers used to save the array in a row wise format, or many compilers used to save the array in a column wise format. Clear? Now this row wise and column wise, why it is different? Because row wise means all the rows will be saved one after the other. You can see in the figure, the first row is being saved with 51, 25, 65, 32. The second row starts from 45, 85, 12 and 97. And the third row is 99, 11, 21 and 54. So this is the way in which the row wise arrangement of the 2D array is being saved. Why it is being done? Why this row wise and column wise is being distinguished? Because a 2D array cannot be saved in the given format in the RAM. All the arrays, whichever array you are going to use, all these arrays is being saved as a 1D array in the RAM. Yes, all the arrays is being saved as 1D array, where the cell numbers is going to change, because again the same way the addresses is going to be in a contiguous manners. After 101 is going to come as, if it is integer, is going to come as 105 only. Then after 105, 109 is going to come, because 4 will be added with the previous values. So this is how the arrangement is being done. It can be arranged in a row wise manner, which is called row measure. It can be arranged in a column wise manner, which is called column measure. So you can see over here the column measure is going to contain the first column at the beginning, then the second column, third column and then the last column. So this is how the arrangement is being done, the arrangement of the rows or the columns. It depends which architecture your computer is going to perform. Now you are going to ask me, sir, which architecture does our computer perform? It depends on the operating system, or rather it may depend on the microprocessors that your computer is going to use, that is your processor. Now many processors use the row measure format and many processors use the column measure format. That is not our concern. Our concern is how to find out the address in these cases. Now see, if I need to find out the address of 12 using row measure only, suppose the address of 51 is 100 and each cell contains 2 bytes of memory. That means for 51 it's 2 byte. For if I'm going to use the row measure, 51 will have 2 bytes, then 25 is going to have another 2 bytes, 65 will have another 2 bytes, 32 is going to have another 2 byte, 45 another 2 byte, 85 is going to have another 2 byte. So how many cells are there before 12 and in row wise format? That is 1, 2, 3, 4, 5, 6 cells are there before 12. So 6 into 2 is 12 plus 100 is 112. If we are going to go with column wise, see the first column contains 3 elements, the second column contains 3 elements, and the third column before 12 contains 1 element. So total 7 elements are there. The 7 into 2 is 14. So if we are going to follow the column wise format or column measure, we are going to have the value over here. The address of 12 is what? The address of 12 will be 114 because 7 cells was there and each cell contains 2 bytes. So 14 plus 100 is 114. But for row measure the address was 112 because 6 cells was there before 12. This is how it is being calculated. Now see the next slide. In the next slide, that is this slide, we are having the address calculation for the 2D array, that is that both the formulas has been given over here. First understand what does this formula means or how it is being written or what are these values, and then we are going to solve the sums. See, the formulas given for row measure is address of A of ij is equals to B plus W into C into I minus LR plus J minus LC, where A of ij, I and J are the row numbers and the column numbers, that is the cell number whose address we need to find. We need to find the address of a particular cell. That cell contains a row number and the column number. Those row numbers and the column numbers is I and J. B is the base address, that is the base address of the first cell of the given 2D array. W is the width, that is the storage or the size of the given data type. C is the total number of elements present in a column. I told you it's a row number. LR means lower limit of the row and LC means lower limit of the column. UR means upper limit of row. UC means upper limit of column. You can see all the abbreviations or all the variables that we had used is the expression has been given at the bottom over here. Now we always have to remember, while we are going to use row measure format, we need to calculate an extra value, that is total number of columns. That means for row measure we need to find the number of columns, and to using a column measure we need to find the number of rows. There is only a simple change in the formula. Everything is same other than this C multiply. You can see this C multiply and R multiplied over here. See, B plus W into the C is multiplied with I minus LR in row measure, where in column measure this R is multiplied with J minus LC. In column measure, R, that means the number of rows, is multiplied with J minus LC, whereas in row measure number of columns is being multiplied with I minus LR. This is the only difference in the formulas. So it's very easy to remember the formula, where C, that is the column number of columns, can be calculated by UC minus LC plus 1. Upper limit of the column minus lower limit of the column plus 1. Why plus 1? Now see, suppose if the number of columns is 5 That means the lower limit is 0 and the upper limit is 4. So 0 plus 4 is 4. 4 minus 0 is 4 plus 1 is 5. Now we are going to get the total number of cells. So now we are going to get the total number of columns. That means the total number of cells which is present in each rows. Similarly, we can get the total number of elements which is present in each column, that is the total number of rows. Make it very simple, don't make it complicated. Number of columns means number of cells present in each row, and number of rows means number of cells present in each columns. So over here we are going to deal with number of columns in row measure format and number of rows in column measure format. Make it simple, don't make it complicated. So now we are going to deal with the next example. The example given over here is an array x minus 15 till 20 and comma 15 till 40, which means the row numbers is starting from minus 15 till 20 and the column numbers are starting from 15 till 40. So the lower limit of the row is minus 15 and the upper limit of the row is 20, and lower limit of the column is 15 and the upper limit of the column is 40. So the first index location or the first cells index locations are x of minus 15, 15. Got it? So the base address of the first index location is 1500 is given in the question, and each cell takes 1 byte. So we have to calculate the address of x 1520, that is 15th row number 15th and column number is 20. So over here we are going to find both the column measure and the row measure wise the index of x 1520. But in your examination any one is going to come. Either we have to find the column measure wise or we have to find the row measure wise. So the number of rows we can find are equals to ur minus lr plus 1, that is 20 minus of minus 15 plus 1. The 20 minus of minus 15 is 20 plus 15, that is 35 plus 1 is 36, where the number of columns is uc minus lc plus 1, which is equals to 40 minus 15 is equals to 1. That is 40 minus 15 is 25 plus 1 is 26. Using column measure wise, the formula was a address of A of ij, where I equals to 15 over here and j equals to 20. B is the base address, which is equals to 1500. W is the width, that is 1 byte. LR is the lower limit of the row, that is minus 15. LC, lower limit of the column, that is 15, and number of rows is 36. So the formula, we are going to plot the values over here and we are going to get the simple answer. We are going to find out the answer, we are going to calculate the answers, and we will get the answer as 1680, which is the address of x 1520. Using row measure, similarly we are going to calculate, we had the number of columns, otherwise the formulas are same. We are going to plot the values and we will get the answer, which is coming over here as 2285. That means 2285. So this is how we are going to calculate the address of a given location. Over here in this type of sums, always remember one thing, that the lower limit and the upper limits are different and is being separated by dots. It may happen in the question in a different book or in a paper, you may find it's written like this: x minus 15 colon 20 comma 15 colon 40. It also means the same thing, That is, the lower limit starts from minus 15. Colon means till the upper limit, that is 20. That means over there also the size or the lower limit and the upper limit of columns and rows are same. Only difference is this question says it's given over here dots, and in the separate question it may have colon or a hyphen or something like that. So don't get confused with those signs or those symbols. Let's move on to the next example. Over here, see, it's a known example or a known type of array is being given over here, whose x of 10, 15, that is the total number of rows is 10 and the total number of columns is 15. As because no initial or the lower limits of rows and columns is not given, so we are going to take lower limit of rows and columns are zeros. See, it's written over the number of rows is 10 and the number of column is 15. So we can find out the column wise, we can find out the address of x512 whose base address is 4500 and it takes an integer data type. Now integer data type means 4 byte. So see, the first line after the column measure wise, the equation is given b equals to 4500, that is 4500, that is the base address. W equals to 4 byte. I is the index whose address we need to find, that is the row number, is 5, J is 12, that is the column number. LR means the lower limit of the row is 0, LC the lower limit of the column is 0, and R, that is number of rows, is 10. We are going to plot all these values in the equation and we will get the answer as 5000. Wherever in row measure wise we are having the column now total number of columns is 15, so we will get the answer as 4800. This is how we are going to calculate. Only remember, if the size is not given as big as the previous example, we are going to take the lower limits as 0. Thank you. So this is how we are going to calculate the sums.